Let's take a look at an activity today. Let's really get things exciting and get things moving by doing one of my favorite things. That's chromatography. Why is chromatography one of my favorite things? Because I'm an analytical chemist. And analytical chemistry is the most exciting field of all of chemistry. It's the field of chemistry that has a multitude of TV shows based on it. Everything from CSI Miami to CSI New York to NCIS. That's right, forensic science is a subspecialty of analytical chemistry. Analytical chemistry is the science of determining what an unknown is. Nearly every single factory out there at some point hires an analytical chemist, either as a means of quality control or as a means of certifying that they're meeting EPA standards with their emissions. Not only that, but you've probably heard of companies reverse engineering products. Who helps them do that? An analytical chemist. An analytical chemist is a person that you give an unknown substance to, and they'll, in return, after several hours, days, months, years of work, they'll tell you what that unknown is. That is one thing I would caution you about the difference between real-life analytical chemistry and what you see in the movies. In the movies, they play a quick music montage and the chemist has the answer. In real life, it usually takes several hours, if not several days or months, to really determine what an unknown's composition is. Now, analytical chemists concern themselves with two basic categories of techniques. The first of these category of techniques are what is known as quantitative techniques. And they're a technique that tells you the concentration or quantity of an unknown. There are also what are known as qualitative techniques. A qualitative technique tells you the identity of an unknown. Or to really simplify it, quantitative tells you how much. Qualitative technique tells you what. A term I'm going to be using probably just out of habit, so I'm going to introduce it to you now, is the term stray eraser mark. Analyte. Analyte is a fancy chemistry way of saying an unknown substance or the substance being studied. In other words, instead of saying unknown substance, I would say the analyte. Analyte is simply a way of saying what's being studied. Perry. Why doesn't everybody write down Perry? Everybody write down Perry. Chromatography is a series of separatory techniques in which substances are separated based on their differing attractions to a stationary versus a mobile phase. In all the labs you'll be doing involving chromatography, your stationary phase is a piece of paper, specifically filter paper. In these labs, you'll be taking your filter paper and you'll be placing it in a liquid. Depending on which of the experiments you'll be doing, you'll be using water in a couple of them. In a couple others, you'll be using you'll be using water as your mobile phase in most of these experiments today. Why is water your mobile phase? Because you'll quickly see in today's experiments that if you place water on filter paper, it doesn't stay in place. It will actually climb up your paper. So because your water is capable of moving, it's referred to as your mobile phase. Into this, you're going to add a couple analytes. You're going to add some copper, and you're going to add some iron salts. They will have different attractions for the water versus the filter paper. Whichever one is most attracted whichever salt, copper or iron, is most attracted to the water will travel the farthest. The one least attracted to it will travel the shortest distance. And that's really how all chromographic techniques work. Things that are more attracted to the mobile phase, such as water, will travel farther. Things that are more attracted to the stationary phase things more attracted to the stationary phase will travel a shorter distance. Used for this is my wife and I going to a party. Now, it's a Sunday, it's after church. I don't want to be at this party. I want to be home watching some football. My wife, however, is delighted to be at the party. She wants to tell everything about everything. So, my wife and I arrive at this party at the same time. I, however, have very little attraction to the party. So I enter this party. I say hello to people as fast as I can. And as soon as I've said hello to everybody, so that I can honestly tell my wife in the car that I talked to everybody, I'm out that door, I'm in the car, and I'm listening to the football game on the radio. My wife, however, she wants to talk to a lot of people. So, if we were to time our locations after, let's say, 30 minutes, my wife may have only traveled to right here because I'm in a hurry to get out and I have zero attraction for that stationary phase. I may be all the way up here closer to the door. And we're going to see compounds doing that as well. Compounds that have a high attraction for your filter paper are going to travel very slowly. Things that have a high attraction for your mobile phase, your water, are going to travel a much greater distance. We can use this to separate components of a mixture. And you'll be doing this not only in today's lab, but you'll also be doing it in tomorrow's lab, or next week's lab rather, that focuses on magic markers. Okay. Why don't you write down Phineas? It seems only right that you write down Phineas. Once you've written down Phineas, we can move on. let's take a look at some different parts of the experiment here. First of all, you're going to have to use filter paper again. If you haven't done so by now, you're definitely out of the filter, probably filter paper that's come with the kit. So go to the store and buy coffee filters. They are super cheap. I believe I paid $1 and I got like 200, and that was at Kroger's. I didn't even have to go anyplace crazy. So you need some coffee filters in order to get your filter paper. Next thing you'll notice is in Experiment 22, they give you a drawing of what they think your experimental setup should look like. And they tell you to use some glass baby food jars with wooden skewers. Now, wooden skewers aren't hard to find. You can find wooden skewers usually in the meat department of Kroger's, but I'll be honest with you, you don't have to go to all that effort, even though they're pretty cheap. What you can do is, rather than a wooden skewer or knitting needle, a pencil will work quite well. I used a pencil and I used a little bit of tape to tape the piece of paper or the piece of filter paper up to the top of the pencil there. And there is nothing magical about baby food jars. Now you want a clear thing, and you don't want something you're going to put food into later. So if you can use a clear you can use a clear disposable cup if you can find one, which is what I did. Rather than use baby food jars, I had a couple glasses left over from a party, some plastic cups left over from a party that I simply used. The shorter the container, the better. Another thing I've also used that you may see some in the pictures is at Kroger's in the canning section. I found they're probably made for canning jams. Some really, really small screw top jars. And I paid 94 cents, pardon me, 94 cents for a really small canning jar. And by that small canning jar, it was maybe 4 inches tall. Probably made to hold jams or something. I don't know. I don't can food. I just go to Kroger's to look for chemistry supplies. No, really, that's the truth. So those are a couple things that you might be able to substitute. Don't feel you have to find that baby food jar, and don't think you have to find some sort of fancy filter paper. Coffee filters work perfectly well. Be careful. You are working with hazardous substances again. As always, wear your chemical goggles. Make sure that you read all the boxes on the page, because some of your pre-lab questions will be coming from those little what's happening here boxes. And I'm going to keep it short and pithy this time. I'm really not going to belabor what we have going on here, and I will let you get on with some chromatography.